And to my knowledge, you've never graphed this equation yet, so the table is really important. So, write the agenda and think about this table. Remember that this is the equation. You take x out, you put -2 in, simplify, and that'll give you your y value. Your goal is to plot ordered pairs, points shown in this table. All right. I don't think very many of you are trying this. You guys, this is not free time. This is not free time. You're supposed to be actually trying to figure this out. And of course, you don't necessarily have to be silent during bell work, but if you are talking, it's supposed to be like working together to figure this out. So today we're moving from graphing linear functions to graphing absolute value functions. And they have kind of a very distinct shape to them. So our agenda today, graph absolute value. Here, to be honest with you, this kind of starts with classwork. I know this says bell work, but this kind of launches you right into classwork today. This table and this graph are really important. So when I complete this table, I'm plugging in to this equation. Y equals the absolute value of x. So if x is -2, I'm going to plug that into the absolute value. And what's the absolute value of -2? +2. So my first point when I go to graph this equation is -2, +2. So you guys continue with that table. Do the absolute value of -1. And then do the absolute value of 0. You guys close your Chromebooks. Nobody needs a Chromebook open. Don't get on a Chromebook right now. Work on this. You gotta figure this out. That's not good. Can you do better? Alright, so far I know I have the ordered pair. X is -2, Y is +2. Alright, the absolute value of -1. What's the absolute value of -1? +1. So my next ordered pair is -1, +1. What's the absolute value of 0? 0. So my next ordered pair is the origin. 0, 0. What's the absolute value of +1? Still +1. Absolute value isn't opposite. It's just distance. So 1 is still 1 units away. So I got 1, 1. And what's the absolute value of 2? 2. So my last ordered pair is 2, 2. Look at that. Draw your picture. I'm going to connect my point. And I'm going to make a statement. should write this statement down and this graph and this table. You should write all this. Absolute value equations have V-shaped graphs. Little statement there for you. So, because the bars turn those values positive, the line doesn't go negative like in a regular linear function. It bounces and stays positive. So that creates that V-shaped graph. It's pretty cool. That's what it looks like. Sorry if this podium's in your way. So I'm gonna tell you something about this. The domain is x values, right? So I'm gonna set D for domain. The domain is all real numbers. But something happens with range. We're talking domain and range. Remember, I'm not talking algebra 2 here. I'm talking algebra 1. Range is y values, right? So all positive because of the absolute value bars, the y values are staying positive. So I'm going to show that. I'm going to say y values are greater than or equal to 0. I like how you said that. All positive. And so you can show that with this symbol. Yeah, sure. So what this is called, I told you guys on Friday that y equals x was the parent linear function. This is the parent's absolute value function. And so today, actually, what we're going to do is we're going to transform this just like we transformed lines. We're going to shift it up and down. We're going to shift it left and right. We're going to flip it. That's called a reflection. We're going to stretch it up and make it skinnier. We're going to stretch it out and make it wider. Okay, so today we're doing all the things we did last week with lines, but we're doing it with the V-shaped graph. And I have a handout for you to help you take notes. So everybody has a handout for the straight lines. Now I'm giving you another handout for absolute value. This whole punch, you can put it in your binder. It's not whole punch? Oh, yeah. All right, guys. So when you look at the top of this is the parent function, like I just said. And this model here is going to help you understand how to move the V shape around. I thought I put one right on your binder. Oh, because you just came in. Put one on Sarah's binder. Yeah. Can you pass that back to Melena? Thanks for letting me know. Did everybody get a handout? All right, so if we have to move the V-shaped graph, if there's a number that shows up at the end of the equation, not in bars, that's going to shift the graph up or down. So if your equation becomes more complicated, for instance, it says y is the absolute value of x, but then it says plus 8 at the end, you just take this graph and you move it up 8, and you redraw the whole thing up 8. You should finish this first. Let's do this first. All right, if there's a number inside the brackets, how do you think that would move the V? That's going to shift it left and right. The tricky thing about a horizontal translation, and that's what I should be calling this, because that's the fancy vocabulary. The tricky thing about the horizontal translation is it's opposite of how it looks. And we saw that last week with our linears. When there was a number in parentheses, you shifted opposite of how it looks. So this is the case. If it says -5, you might think towards the -5, but you actually go opposite. You go right 5. And the last thing we're going to do, the A value does so many things I almost can't even fit it. Hope you guys have room. I have to erase what I did here because I ran out of room. Sorry if I messed you up. So A, all the things A does. If A is negative, then the graph is flipped across x-axis. That's called a reflection. I still don't have room. If A is greater than 1, then it's a stretch, meaning it's skinny, tall and skinny. Yes, Winter? Yeah, if you look down here at number 5, that's an example. So, and we're going to work up to number 5, but number 5 has a shrink, it's right 4, and it's down 3. So, it's all one shape. Yes. It's all the same thing. You know what I should just tell you about A? I'm going to come up here. A is the slope of the right branch. is the slope of the right branch. Sorry if you don't have room. I'll show you real quick. You don't have to write this one down, and we're gonna do it. But if it was 3/4 times the absolute value of x, I would start at the origin, and then my branch would be up 1, 2, 3 over 4. Up 1, 2, 3 over 4. And then this one would look just like that one. So this is the slope of the right branch, and then you kind of mirror it on the other side so that it's symmetrical. Okay, so A does a lot of good stuff. All right, number 1 is the horizontal translation. We want to move the parent function h units to the left or right. So let's make a note. This minus 3 in here, move 3 units right. So I'm going to, on all of these, I'm going to draw the parent function, which is at the origin and up 1 over 1 on both sides. That's y equals x. And then I'll draw the new one. 1, 2, 3, it's 3 units to the right, and copy the same V shape. That's too thick. Boop. Boop. That's it. We just gotta move it. I just take this one and I just boop over to the right, do the same thing. Yeah, well, you can sit here today since that desk is open if you can't see somebody. I think that's the worst desk in the room over there. It's so hard to see. People like it. No one wants to move. I guess it's comfortable, but I don't know how you guys see. So you got the one in the middle? Yeah. Yeah. And then it's just straight up diagonal. So you don't have to do anything? What do you mean by do? Like you don't have to work. It feels like it should be harder, but that's it, yeah. It's just up 1 over 1. There's no different slope. This just means everything's gonna be 3 to the right. Okay? Now let's go to number 2. The main thing is memorizing this. Memorizing that a number in here is a shift right or left, whereas the number at the end, not in the brackets, is a shift up or down. So this one is the parent function, but we're going to move 2 units up. So I'll put the parent function in again. The absolute value bars create this V shape. That's cool. But there's a plus 2, so every y value on this one's going to be up 2, so I'm just going to count up 2 and draw it again. There we go, up 2. What if that was a -2? It would go down to. Good question. Yeah. What's that? Oh, it'll make it steeper and slow. Slope of the right branch. It'll make it taller, steeper, or lower, flatter. Yes. Cool. So you ready to go, Colin, or you want to stay and do math? Yeah. Okay. I'm going to flip the graph over. I'm going to flip it down. So I'm drawing the parent function again. And now, since there's a negative in front, actually all the y values will end up negative because we'll multiply by -1. And there it is, flipped over. It makes an X ultimately, but really it's just two V shapes. Flip it over. Now it's going down. I hope, on all of mine, I have the green one in the middle. I hope you guys are doing that too because, if you don't remember what the green one looks like, you can't shift it around, right? So remembering the green one's important. So I hope you're drawing the green one in. Okay, on number 4, there's a number in front. That A value, sometimes is called a scale. It can be called a stretch or a shrink. It affects if it's skinnier or wider. So it's not exactly too much like that one. So this 3/5 is going to be the slope of the right branch. So I'm starting in the same place, 0, 0. But instead of going up 1 over 1, I'm going to count up 3 over 5. And it's going to make it look flatter or wider. It's a less steep slope because the value of A is less than 1. Now, the trick is like matching that on the other side. So I have this, it's always a V. If there's absolute value, it's always a V. So I have to follow that same up 3 over 5 going the other way. This is only the case when there's absolute value bars in the equation. Who's got a question on these 4? If you have a question, it would help to speak it out because probably other people are feeling the same way. It can be really hard to figure out what to ask, though, I know. Yes? Mm-hmm. Mm-hmm. Vertical, you could go down if it was a minus, yeah. It's up or down, left or right, flipped, skinny or wider. Those are all the moves. All right, let's put it all together. What's that? Which one? Any of them? Yep. So, yep, you start with the parent function. You start with this shape, and you're moving this shape around. Yeah, for the regular parent function, yeah. Good. Who else has something to add? Question. For that one? What do you, like, how do you do it? This one here? No, that. This one. So instead of like the green one, I don't know if you've noticed, is always up 1 over 1, up 1 over 1. This is the new rise over run of just this side. So I just counted up 3 over 5. This I have to follow the same slope the other way. So I went up 3, but I went left 5. Okay? Okay, and in this last one, we're going to put it all together, everything but the flip. So start with the one in the center. It can be really difficult to do 3 changes at once. So this is a good hint that H and K are the center point. The center point is often called the vertex. Okay? So, what do I mean by HK? Well, when I look at the top, the number in the bracket is called H, and the number at the end is called K. That's the vertex. So 4 and -3, that's like the H and the K. So 4, -3 is the center of this parabola. Because from 0, we have to go right 4 units and down 3 units. So there's my center point. 4, -3. Mm-hmm. Not unless there's an exponent, a square root. This is the whole function family of absolute value bars. So if the independent variable x is inside absolute value bars, it is a V shape every time. It's just like if our independent variable x is squared, this is always a U shape. A parabola. If it's in bars, it's always a V shape. If it's nothing, if it's just y equals x, it's a plain old flat line. Okay, so these are function families. Plain old lines, V shapes, U shapes. You want to know? This was a learn how to do that. The U shape, yeah. And then in algebra 2, you do x to the 3rd power. That's an S shape. Every time. Okay? And then in algebra 2, you also do x to the 4th power. And a lot of times, that's a W shape. And we move that right, left, up, and down, and we flip it over. So all the things you're getting introduced to now with lines and V shapes, you do it again in algebra 2, and the shapes are different, but you're still just moving them left, right, up, and down. Okay, so I got my center point called a vertex. Now the 1/2 affects the slope, right? There's an A value or a scale of 1/2. So this means that the right branch has a slope of up 1, right 2. And then I have to match that up 1, left 2. So this is the new equation. It's shifted to the right, it's shifted down, and it's been smushed. It's been smushed by 1/2. It's half as tall as the original. Slope is up 1, right 2, instead of up 1 over 1. Yes. Yep. All right, your assignment is in Big Ideas Math. I'd like to help you with it. So go ahead and log in and get into that, and I can help you work through it. You guys don't put your things away, right? You need this handout. This is what's going to help you when you have a question. So leave this out on your desk. Leave this out on your desk so you can refer to it. There's vocabulary here. Anybody find it Mine is a low major. You want blue? My school All right, number one, you guys, I gotta tell you something. I didn't cover domain and range just now as much as I wanted to, so I'm gonna go ahead and tell you that you guys, I need to tell you about domain and range. A shift up or down will affect the range. The affects affected us. I think that's effect. Okay, so, and I can tell you right now that the domain is always all real numbers for absolute value. So I told you that, and the range is shown as a weird inequality symbol. Now, if there's a shift up or down, it affects this number here. So since this has a shift down one, the range then becomes y is greater than or equal to -1. Because it's not at 0 anymore, it's down here. So when you move a graph up or down, the amount you move it up or down shows up in the range. So I think number one asks you domain and range. Domain is all real numbers. In range you have to type in. Or can you drag and drop in there? Oh, yeah. Those are pretty straightforward. Those are good questions. See if I can get mine to load. No? No, somebody's out right now. All right, so this one is a vertical translation down. Domain is all real numbers, and range is y is greater than or equal to -1. Yeah, you need to move it so that you're down. So on number one, you don't need to put in the parent function in the middle. Just put it down one. Just put the down one. You don't have to show two. No, I think it's a drag and drop. You click the answer in. Don't panic, just click undo. So we'll come around, you ask me a question, ask me a question.
Oh my God, it's making my outside it's not it's down.
Sounds like you need 3 dollars. So that one is You're on number 2, Travis? All right, number 2. Inside the brackets, moves left, right. So a +4 means move the V shape left 4 units. And I think when you click, you can only have like 3 points. You can't click all over the place. So I'm going to go 1, 2, 3, 4. I'm going to click a dot here, here, and here. I think is the only 3 dots you can have. But you guys might need to click around a little bit and figure that out. That's why you have unlimited checks, guys. Just try to get that graphed in as little dots as possible. I've never